The JavaScript garbage collector, which is what we call the JavaScript automatic or dynamic memory management system, is very effective and does a great job in all versions of the JavaScript engine if the programmer does their part. Although the engines are owned by different companies and are slightly nuanced in how they implement the ECMAScript standards, they all work so seamlessly that most JavaScript developers don't often think about memory management until something goes wrong in terms of errors or slow performing apps. There are actually more JavaScript engines than is what is shown in this image. There are already many videos on YouTube and other platforms covering the JavaScript memory allocation concept, which are mostly very good and is an important concept to understand. What I feel is lacking is a practical application of this concept demonstrated in an actual computer program. I will attempt to rectify this in this video. Most of the time, an array in JavaScript is created in a program by human developers like this via an array literal, allowing the JavaScript engine to manage the particulars for us. Then we populate the array programmatically at some point in our application without thinking about pre-allocating memory for it, which means defining how many elements the array will have when we declare the array. In other computer programming languages like Java, C, Rust, or Go, whenever we declare an array, we have the ability to pre-allocate and specify how many members that array will have along with its type. Some people will say that in TypeScript we can pre-allocate members of an array along with its type. However, this is just syntactic sugar. The TypeScript runtime is actually the JavaScript runtime. If you recently started programming in JavaScript after having spent some time programming in some other languages, you might not be aware that in JavaScript, we have the ability to pre-allocate the elements of the array at declaration time as well. We might not have the ability to specify the type, but we can most certainly pre-allocate the elements of an array at declaration time when it makes sense to do so. If we declare an array as an array constructor like this, and when I say we, I'm referring to human programmers as well as generative AI that we humans have trained and have developed their large language models. We have the ability to specify the number of elements that will go into this array at declaration time. There are use cases where this is useful and very performant. However, there are also cases where this approach is very inefficient. For those of you who suffers from insomnia, this is the official documentation from the ECMAScript TC39 commissions themselves regarding the array constructor. Some of you may prefer to read this type of documentation from the Mozilla Developer Network. The scenario where pre-allocating can be very beneficial is if you know the exact size of the input of your function ahead of time. Take, for example, this vessel, where we know the exact volume size of our cargo compartment and the size of the individual cargo payload that will go into the compartment. Let's say satellites, for example, ahead of time. Furthermore, we know that the vessel will not launch unless we have a full payload. Otherwise, we wouldn't make any profits. The payload volume here represents the input size of our array. Therefore, we can write a function with an input array that is the exact size that we need, so that the JavaScript engine does not have to resize or shift elements within the input array. The index of the array is constant, and the JavaScript engine can optimize memory usage and access patterns. And so access and assignments are always going to be all of one or constant time. This really helps with reduced power JavaScript engine like Hermes, which is the JavaScript engine that is used for React Native. And if you're not familiar, React Native is the framework that is used to generate native mobile apps from the React JavaScript library. So in code, we can declare an array with a specified length that will be the length of the 6 individual payloads within the cargo compartment. So let's change this up a little bit. Let's write a function that will take an input string that represents our cargo manifest for our cargo compartment on the ship, and a target or targets plural string which will represent the specific cargo that we are looking for. The function will return a pre-allocated array or output array that will contain the number of occurrences of the target or targets, or the string not found if the target is not found within the cargo manifest. So essentially, this is an occurrence or frequency algorithm. If we call this function, the end state will look like this. So in this example, when I invoke the function with a manifest of ABC, of course we lowercase the name of the cargo to get consistency. If I'm looking for H, clearly H is not within the manifest, not within the input string, right? So therefore the array will have an element of the string not found. And then for C or Charlie, cargo Charlie is here, right? It's within the manifest. So and it occurs one time, right? And so we return the number 1 within the array. The function will start out like this. Basic error checking. And as I mentioned earlier, for the sake of consistency, we will lowercase the input string as well as the target string. And then we will replace anything that is not a string. Next, I want to create a native JavaScript map. I'll call it string map. I'm creating this map because I want to eventually loop through the cargo manifest, which is represented by the input string, and then create a hash map and maintain a count in one pass of each cargo in the manifest, which is the input string here. I'm using JavaScript map natively instead of an object literal because it's easier to do with a map, is faster. Map has a get and set method that's easy to get and set from this input string and set the each individual string as a hash map. I'm using a basic for loop to loop through the input string, which is our cargo manifest, because the for loop has very little overhead and is fast. And I'm doing everything I can to speed up the loop, including caching the length of the input string here. So basically, we're looping through the input string here, and then we're setting the map with the count of each letter, which represent each cargo, each pieces of cargo within the cargo manifest that we're supposed to have. So after we loop through the input string, this map on line 11 is empty, right? But once it hit this point, the map will look something like that. On line 19, as you can see, I've created an output array via the array constructor. This array will ultimately be returned by this function after we do some more work. But the length of this array is pre-allocated to be the length of the sanitized target. And of course, the sanitized target is just a target that's been sanitized. And so therefore we have consistency here, right? We have consistency here, and the application will perform much better with this array being allocated. Okay, let's do some more work. So by the time that we get to line number 21, where I loop through the sanitized target, the map, the string map here, hash map, should already been filled if there are no errors in the program. So I will loop through the sanitized target, and then since the string map is filled, I can look inside the map and see if any of the target cargo is inside of the input string, which represent the cargo manifest, right? And if there is, we assign it to count. And then since we have this output array here, which again, this is already pre-allocated, and we can simply do assignments, right? We can assign the elements. So a little bit of error, a little bit of defensive coding here. So if the cargo is present inside of the cargo manifest and is not undefined, then we will assign the count, right? 1, 2, 3, whatever, to an element of the array. Otherwise, we will print out not found within the array. And then, of course, we return the output array. In terms of time complexity, we can describe it as O of n plus m. The total time the function takes grows linearly with the length of the input string, represented by n, plus the length of the target string, represented by m. In other words, the function processes each character of both strings once. So the running time increases proportionally to the combined size of the two inputs. In terms of space complexity for this function, it is O of k plus m, which means that the amount of memory that the function uses grows with the number of unique characters in the input string, represented by k, plus the length of the largest string, represented by m. This means that the function needs space to store information about each unique character that it finds, as well as the space for the result for each character in the target string. Please remember that pre-allocating a JavaScript array is a unique use case scenario where you have to know the input size and output size ahead of time for it to be worthwhile. Now, admittedly, if this array runs out of room, the JavaScript engine can reallocate space and expand this array dynamically at the cost of a performance hit. And so therefore making this whole um, pre-allocation thing a moot point, right? So again, this is a niche scenario uh, where you would not want to use this technique is if you're dealing with data that you have absolutely no control over. It could be from a third party or a fourth party or a fifth party or whatever. You don't know ahead of time what the shape of data will look like. So, um, but if you do know what the data looks like ahead of time, then this can be very fast and very efficient and very performant, especially when you're dealing with devices that are low powered. Okay, my dear friends, I hope this was helpful for you. If you're not yet a subscriber, please consider subscribing to my channel. It does not cost you anything, and perhaps in the future it will help me out a little bit. Thank you for watching. I'll talk to you next time. Goodbye for now.